Hello everyone, welcome back to my channel. So today we're gonna go over this problem of controls. Uh, so let's read through this problem. This problem shows a block diagram and there are appropriate constants C1, C2, and C3 that may be found for the block diagram in figure 4 to represent a system with input UT, output YT, and governing equations x1 dot equals -3x1 minus 2x2 plus u, and x2 dot equals 4x1 minus x2, and y equals x2. We want to determine the value for the constant c1. So the first thing to do is to take the Laplace transform of these equations and get them all in terms of one equation. So because we have three unique equations over here, so the Laplace transform of, I'm gonna write x1 dot as x1 prime, since that's the form I'm more used to, and it's equal to -3 Laplace of x1, and then -2 Laplace of x2 plus Laplace of u. And Laplace of x2 prime equal to Laplace of 4x1 minus a Laplace of x2 and a Laplace of y. Sorry, y. Yes, so is equal to Laplace of x2. Now let's look at our Laplace formulas in order to know what this is equal to. So here are our Laplace transform equations. We'll be using specifically this equation over here. So let's go back to our problem. Yeah, so basically, as you see over here, mm, Laplace of the first derivative, so s to the power of n is equal to the first power. So we are going to have x1s, x1 s times s to the power of 1, and then it's going to be minus initial condition. But over here, we're not really given any initial conditions. Let me see. Yes, all the initial conditions are 0, and this will be equal to, and because of that, like, we don't have any plus whatever over here. So this is just equal to -3 x1s, and then -2 x2s plus u of s. And Laplace of x2 prime is equal to s x2 to s, and this is equal to 4x1 s minus x2 to x2s. Okay, and then the last one is going to be ys, and this is equal to x2s. So we'll get it all in terms of one variable. We see that we have us over here, we have ys over here, and we want to get it in terms of us, x2s, x1s, and ys. So what we do is we plug in ys for x2 of s over here, and in our second equation, so that would be sys equal to 4x1s minus ys. And then, no, wait, sorry, I misspoke. We are not trying to get it into one equation. We're just trying to get it into in terms of ys, which is the output, right? ys is the output. So that's why we're trying to get everything in terms of ys or with ys in the equation. So now we substitute ys into this equation and we get x1s is equal to negative 3x1s minus 2ys plus us. And these equations mean something. What do they mean? And let's try to rearrange these two equations to get it only in terms of ys. So we have for the first equation over here, it's equal to s times ys plus ys. So actually, wait, hold on. Let's factor out ys instead because that's actually what we want to do. So it's equal to ys times s plus 1 and is equal to 4x1s. And basically s is equal to 4x1 s over s plus 1. Uh, so 4x1s, yes. And what is x1s going to be? It's going to be, let me see. Let's not worry about that first. Let's solve for this other one. So solving for ys, we have 2ys is equal to negative 3x1s minus sx1s plus u of s. And we divide both sides by 2, so y of s is equal to negative 3x1s over 2 minus sx1s over 2 plus us. So as you see, we have x1 of s in both of these. So yeah, y of s is equal to 4x1 of s over s plus 1. So we haven't defined x1 of s yet and x2 of s. So let's let x1 of s be this portion over here and x2 of s. And we know this from the equation because basically, let me see, did I substitute it incorrectly? Yes, we got everything in terms of x1 of s. So yes, x1 of s is equal to 4x1s over s plus 1. But I was a little stuck on what to do, so let's look at what the AI says first of all to gain a better understanding. So first we identify state variables in the diagram, and from the diagram, each integrator 1 over s corresponds to a state variable. The first integrator output is x1 of s, and that corresponds to x1 of t. The second integrator output is x2 of s, and that corresponds to x2t. And let's look at our diagram. And basically over here, this is our first integrator. This is our second integrator. So the output from the first integrator, which is 1 over s, is going to be xs. So that is going to be this one over here. And the output from our second integrator is going to be x2 of s. And x1 dot is equal to the sum of inputs into the first integrator, and x2 dot is going to be the sum of inputs into the second integrator. So we look at the first summing junction, the one feeding into the first integrator, and inputs into this summing point are US, C2x2s, and C3x1s. Now let's think why these signs are like that. Okay, so let's think about what this really means. So we have x2s over here being fed through C2 of s into this block. So we have three inputs at this junction. And it is going to be negative because this sign over here is negative. And so here in the time domain, we can come up with this equation. So basically x1 dot, which is the sum of inputs into your first integrator, is equal to negative c2x2 negative c3x1 plus u. And we compare this to the given equation, which is as such. Over here, x1 prime is equal to that equation, and we can see that that C3 is equal to 3 and C2 is equal to 2. Now let's look at the second integrator whose output is x2. So the input comes from the sum of C1 x1 and negative x2, and let's see why that is. So over here we see that we have xs being fed into this second integrator over here. Um, and what else? And it also comes from C1 x1, which is over here. So yes, that's the sum into the second integrator. Basically, I guess how this works is that we take this portion and it goes into the first integrator, and then the things that go into the second integrator is the combination of these terms. So since the sum comes from this x2 dot is equal to c1 x1 minus x2, and we compare this to the given equation, which is 4x1 minus x2, and we can see that c1 is equal to 4. So I guess these two equations over here, uh which is which are these ones? Hold on. Let me see if I can annotate this. Yeah, so these two equations over here uh, are actually, or no, these two equations over here are actually of that form, I believe. And they represent the left and right summers. As you see over here from, yes, they're basically another way of writing the two equations that we found in the AI. And we see also that it's equal to 4. So let's look at yeah, so over here you see that there are these equations. So this equation with the u, we see we have -3 and -2. And now if we look at over here, we also have -3 and -2. And similarly for the y-s equation, we have x2 prime, x2 dot equals c1 x1 minus x2, and we also found that over here. Yes, and then actually, yes, I was referring actually to this equation down here. The 4x1 minus x2. So that's the equation we found here. 4x1 minus x2. That is another way of writing the equation. So, oh yes, and we can also see that because if we plug back in x2s for y of s, and also over here, if we plug in x2 of s for y of s. I think the confusion was that we shouldn't combine the equation like this as I did. This is the correct way to think through the problem. So I hope this problem was helpful for you guys. And basically, to summarize, the correct answer is going to be uh, C1 equals to 4, of course, as we found. Uh, Wait, hold on. Yes, it's going to be equal to C1 equals to 4. And here are some block diagram schematics that you guys can go over on your own time, but I'll be posting these slides afterwards as well. Thank you guys so much for watching.